Something impossible just happened inside our solar system. A frozen interstellar object known as 3I Atlas has begun to behave like it's alive, and astronomers have no idea why. In this video, we'll uncover how this mysterious visitor from another star system defied every known physical law as it reached its closest point to the Sun, an event scientists call perihelion. What they saw next changed everything they thought they knew about interstellar matter. It began like any other distant discovery, a faint streak of light cutting through the emptiness beyond Jupiter. The Pan-STARRS Observatory in Hawaii had detected strange activity within the Atlas survey data, a fast-moving object unlike any asteroid or comet previously catalogued. The year was 2019, and astronomers quickly realized this was not native to our solar system. It was moving too fast, on a hyperbolic trajectory, one that meant it came from somewhere else entirely. They named it 3I Atlas, marking it as the third interstellar object ever detected after the now infamous Oumuamua and the comet Borisov. At first, 3I Atlas seemed ordinary, another icy traveler from the deep galactic void. But as it approached the Sun, its brightness began to change in ways no comet should. It pulsed, it shimmered, and then it began to spin. What caused this behavior? Was it a simple case of sublimation, ice turning to gas under the Sun's heat, or was something else forcing it to behave this way? When scientists ran the data again, the trajectory didn't line up. The acceleration didn't match the expected pattern for a natural object. Something inside Atlas was pushing back. By the time 3I Atlas reached perihelion, the moment of its closest approach to the Sun, something extraordinary occurred. Instead of disintegrating under intense solar radiation, as most comets do, Atlas appeared to emit a structured burst of plasma, synchronized across its surface. The Solar and Heliospheric Observatory, SOHO, caught the moment in its coronagraph. A luminous flare, sharp, geometrically confined, shot outward, followed by a faint electromagnetic ripple extending far beyond the comet's tail. Astrophysicists initially dismissed it as a data glitch, but when three separate observatories, SOHO, STEREOWAY, and even ground-based instruments, confirmed identical readings, the anomaly became impossible to ignore. It wasn't just a flare, it was a pattern. The plasma bursts repeated in 3-second intervals, almost like a signal. Was it a coincidence, a magnetic feedback loop, or something we've never seen before? For the first time, scientists began to ask if 3I Atlas might not be just a frozen rock. Could it be reacting to the Sun, as if responding to it? To understand the significance of Atlas, we have to go back to 2017, when another interstellar visitor shocked the world. Oumuamua, the first object ever detected from beyond our solar system, was unlike anything astronomers had seen. It had no tail, no visible outgassing, and yet it accelerated as it left the Sun. Some claimed it was a fragment of a shattered planet. Others, like Harvard's Avi Loeb, speculated it could be artificial, a piece of alien technology drifting through space. The idea was controversial, ridiculed by some, yet never fully disproven. Now, years later, with Atlas showing eerily similar and even stronger anomalies, the debate has reignited. Could two separate interstellar visitors both exhibit behavior that defies physics and still be random? The odds are astronomical. When scientists compared Atlas's light curve to Oumuamua's, they found irregularities in rotation that followed the same non-gravitational pattern. It was as if something inside these objects was adjusting their spin, a self-correcting mechanism. What kind of natural object behaves that way? And if it isn't natural, then who or what sent it? In April 2025, just days after Atlas reached its perihelion, a team at NASA's Goddard Space Flight Center released something shocking. Using solar observation data, they discovered that Atlas's flare wasn't random. It was synchronized with a temporary distortion in the sun's magnetic field. For roughly 11 minutes, the local heliospheric magnetic lines wavered, like a string being plucked. Instruments aboard the Parker Solar Probe confirmed the disturbance. A pulse of charged particles, perfectly aligned with Atlas's coordinates, had emanated outward, not inward. This was backward. Comets don't project energy toward the sun. They react to it. Yet the data showed a feedback loop, as though Atlas had responded to the sun's magnetism, then echoed it back. Theories spread rapidly across online forums and academic circles alike. Was it a coincidence of resonance frequencies, a natural feedback between plasma fields, or was Atlas deliberately transmitting something? NASA's official statement was cautious. The anomaly observed during perihelion remains under investigation. But off the record, one researcher reportedly said, "If this were a spacecraft, it would look exactly like this." Where did Atlas come from? Tracing its trajectory backward, astronomers determined it originated somewhere between the constellation Lyra and the Vega system, about 25 light-years away. That's disturbingly close in cosmic terms. What's more intriguing is its velocity, roughly 30 kilometers per second relative to the Sun, a speed consistent with an object expelled from a star system through gravitational slingshot. But the shape of its orbit didn't match a random ejection. It appeared too precise, like a calculated trajectory through interstellar space. If Atlas was just a rock, why would it follow such a narrow, direct path? Some astrophysicists began to whisper about a possibility too bold for academic journals. What if Atlas was sent? Perhaps not a ship, but a probe, ancient, automated, still functioning after eons of travel. Something launched by a civilization long gone, yet still operational enough to react to starlight. Could this be a message not meant for us, but for the sun itself? During Atlas's closest solar encounter, radio telescopes detected something even stranger. A low-frequency oscillation, measured at 2.11 Hz, appeared briefly in the background of solar emissions. At first, it seemed like interference, but when cross-referenced with Atlas's position, the signal aligned exactly with the object's trajectory. It wasn't a steady tone, but a pattern rising, pausing, falling, repeating every 90 seconds. Astronomers at Arecibo had once called such patterns unnatural periodicity, the same kind of rhythm expected from artificial beacons. The frequency appeared again, faint but measurable, as Atlas exited perihelion and began its retreat. Could the sun's radiation be activating something within Atlas? A latent resonance, an embedded structure, or a core of conductive material designed to awaken under solar exposure? Or is it all coincidence, an echo of natural harmonics we still don't understand? Every answer led to more questions, and every question led closer to something that felt uncomfortably deliberate. By mid-2025, Atlas should have disintegrated. That's what physics predicts for small interstellar comets at perihelion. Heat, pressure, and solar wind tear them apart. But Atlas didn't fragment. Instead, it appeared to hold shape, even as its brightness dimmed unnaturally fast. When high-resolution imaging tried to confirm its nucleus, something baffling appeared. The light signature didn't match a solid body. It looked hollow. Could Atlas be a shell, perhaps metallic or carbon-based, rather than a dense core of rock and ice? The European Space Agency noted an odd reflective consistency across multiple wavelengths, as if the surface was composed of layered material, almost like insulation. In other words, Atlas might not be a comet at all. In June 2025, NASA quietly updated its heliophysics data archive. Buried deep in a minor press release was a line few noticed. Unusual photometric fluctuations associated with 3I Atlas remain unresolved due to non-conventional light scattering properties. Non-conventional light scattering. That phrase set off a storm in the astrophysics community. To experts, it meant one thing: the object wasn't reflecting sunlight like dust or ice. It was redirecting it, possibly through refraction or even structural manipulation. Privately, several scientists began to suspect that Atlas contained some form of internal geometry, panels, lattice structures, or layered composites. One anonymous engineer, formerly at JPL, told a European reporter, "If you were designing something to survive interstellar travel and solar heating, it would look exactly like Atlas." Was this a coincidence? Or had we just witnessed the first interstellar artifact passing through our star's domain? When Atlas moved beyond Mars's orbit, most telescopes lost visual lock, but radio observatories continued to listen. For weeks, faint echoes, electromagnetic pulses in the same 2.11 Hz band, were detected bouncing through the heliosphere. These weren't strong enough to transmit information, but they followed a rhythmic decay pattern, almost like a heartbeat fading into the void. Scientists called it the Atlas Pulse. It gradually disappeared by August 2025, but many wondered, what if it didn't end? What if the signal was now traveling beyond Earth's detection range, carrying data back to wherever Atlas came from? And if that's true, what message did it send? In the grand scale of cosmic history, Atlas's brief visit may seem insignificant, a passing traveler from the darkness beyond our stars. Yet its behavior has left a scar on human understanding. For decades, we've looked outward, searching for signs of intelligence. But what if intelligence occasionally passes right through us, silent, unacknowledged, and ancient beyond imagination? Was Atlas merely a rogue comet from another system? Or was it something older, engineered, and aware, following a path set millions of years ago? As it drifts away into interstellar space once again, one question remains. Was this encounter an accident or an experiment? Because if Atlas truly responded to our sun, if it echoed back magnetic pulses in precise intervals, then it wasn't observing the solar system. It was communicating with it. And perhaps the universe just replied,